Hello friends, today we will see about the superposition theorem. The superposition theorem states that the response in any element of a linear or bilateral network containing more than one independent sources can be obtained as the algebraic sum of responses obtained by each independent source acting separately at a time, and will all other independent sources set equal to 0. While evaluating the response from one independent source, other source cannot be removed broadly from the circuit. Instead, you suppress all the independent sources by setting their value to 0. The suppressed source then behave like the following replacement. Ideal independent voltage source acts as a short circuit. An ideal independent current source acts as an open circuit. To understand the superposition theorem, we have taken here two application or two example for better consideration. First example, determine the value of I1 using superposition theorem in a network of figure. Here I1 is shown here, that means we have to find current through 2 ohm resistors. For that, first of all we have taken a 30 volt source, while all other source replaced by 0. It means it is an independent current source and hence it is acts as an open circuit. Here is also current source, hence it is also acts as an open circuit. Now, to find the current through 2 ohm resistors, we can simply apply the equation, that is I1 dash. What is here I1 dash? I1 dash is current flowing through 2 ohm resistors, that will be equal to 30, that is voltage divided by 6 plus 4 plus 2, that is equal to the resistance, that is 6 ohm, 4 ohm and 2 ohm, as the current will be 2.5 ampere. Here the direction of current shown as in downward direction. Now we take on another source, that is 3 ampere. Now using 3 ampere source, we will find the current through 2 ohm resistor. The current will be given by I1 double dash, that will be equal to 3, that is the independent current source multiplied by 4, that is the resistance parallel across the current source, divided by 6 plus 2 plus 4, that is total resistance, which will be equal to 1 ampere, that will be in downward direction. Now why this equation is used? This equation is used because here a resistance is connected parallel with the current source. Now we will see the 8 ampere source. For that, we will consider voltage source as a short circuit and current source as an open circuit, as the current through 2 ohm resistors will be equal to I1 triple dash, that will be equal to, here 8 ampere source is given, but the direction of we have to initially find in downward direction as we have considered. For that, 8 ampere current is reverse direction, because it will be flow from this to this path. Now 6, that is the parallel resistance, and total resistance 6 plus 2 plus 4, the equivalent will be minus 4 ampere, that is in upward direction. Now, as the superposition theorem says that the determined value means to current through 2 ohm resistance will be equal to I1 dash plus I1 double dash plus I1 triple dash, that will be equal to simply 2.5, which we have gained earlier, then 1 and minus 4, The total will be minus 0.5 ampere. Your minus sign shows that the current direction is upward. Why it is upward? Because initially current direction we have taken in downward direction. But as here minus sign comes, that means it is in upward direction. Now we will see another example for understand the superposition theorem. That is use the superposition theorem to find the value of V across 20 ohm resistance in the network of figure. Here the network is given and the voltage across this 20 ohm resistance we have to determine. So that first of all we will find the current through resistor 20 ohm, that is I1, and for that we have drawn one network. Now what is this network indicate? This network indicate 24 independent voltage source, while current source is open circuited and voltage source is short circuited. Hence the current will be equal to why here this equation is applied? Because here also the current is divided. Let's see how it's happened. The current through 20 ohm resistance, for that here 24 volt supplies here. Now current will be passed through 10 ohm, current will be passed through 20 ohm, but here there is a two branches, 30 ohm and 45 ohm. For that we need to apply a parallel rule, and that parallel rule is 30 multiplied by 45 divided by 30 plus 45. The equivalent answer will be 0.5 ampere. Hence the voltage across 20 ohm resistors will be equal to 20 multiplied by I1, which will be equal to 20 multiplied by 0.5, which will be equal to 10 volt. Hence this is the voltage due to 24 volt source across the 20 ohm resistor. Now we will consider another ideal independent source, that is 48 volt. Now for 48 volt current through 20 ohm resistance, we will use same equation for deriving the value of current, and the equivalent current I will be equal to 48 divided by 45 plus 30 multiplied by 10 plus 20 divided by 30 plus 10 plus 20. The equivalent answer will be approximately 0.8 ampere. Now 48 volt is a supply voltage, 45 is this resistance, and 30 multiplied by 10 plus 20, because here 30 and here is 10 plus 20, that is in parallel connection, while these both are in series connection. Hence the series combination and with parallel combination of 30 ohm. As the equation used here is 30 multiplied by 10 plus 20 divided by 30 plus 10 plus 20, and the answer will be 0.8 ampere. Now current flowing through 20 ohm resistance will be given as I2. We give name as I2. Now minus 0.8. Why minus 0.8? Because current is going through this path. Hence we give name as a minus 0.8 multiplied by 30 divided by 30 plus 30, which will be equal to minus 0.4 ampere. Now current through 20 ohm is derived from the current division rule. We have to find the current through this path. Hence we have taken opposite resistance, that is 30 ohm, plus total resistance, that is 30 ohm plus 10 plus 20, which is equal to 30 ohm. That will be equal to minus 0.4 ampere. Now voltage across 20 ohm resistance will be equal to minus 0.4 multiplied by 20. That will be equal to minus 8 volt. That will be voltage across 20 volt resistance due to 48 volt supply. Now for 2 ampere supply, we will see how to derive the voltage across the 20 ohm resistance. For that, first of all, we will find current through resistance. The current division rule will also applicable to here, which is equal to 2 multiplied by 10, that is opposite branch, divided by 10 plus total resistance, that is 10 plus 20, plus these both are in parallel, 30 and 45, hence 30 multiplied by 45 divided by 30 plus 45. The equivalent answer will be nearly equal to 5 by 12 ampere. That will be current through 20 ohm resistance due to 2 ampere source. Now voltage across 20 ohm resistance due to 2 ampere source, that will be equal to 20 multiplied by 5 by 12, that will be equal to 100 by 12, that will be equal to 8.33 volt. Hence we have derived the voltage across 20 ohm resistance due to various source, that is 2 ampere current source, 48 volt and 24 volt, which was at here. Hence the total voltage across 20 ohm resistance will be given by superposition theorem, that will be equal to V1 plus V2 plus V3. What is V1? V1 is 10. What is V2? V2 is minus 8. And what is V3? V3 is 8.33. As the total voltage will be 10.33 volt. Hence the superposition theorem is used to solve such a network. If you like this video, please subscribe to channel for getting more updates.